Good morning. Might as well get started. My name is Marten. I'm the product manager for what is called Esri's Geoportal Server, which is essentially a metadata catalog that works in various different settings. And what I'll go through here is those settings of what Geoportal is, where Geoportal is used, and also talk to you about some of the development we have done over the last year and where we're going from here also. So Geoportal Server is used, as you can see here, in what we call heterogeneous environments. So environments where not everything is ArcGIS, not everything is Esri technology, but different metadata catalogs, different web services, most notably OGC services are being used, and people create these catalogs sometimes even outside of organizations specifically, right? So there's an external site where you can go to find things and use them in whatever your use case is. So typically search and discover, view the metadata, edit metadata is a large focus of this product, and then sometimes downloading data as well. It's been around for quite a while, and it has gone through several iterations. We started off with ArcIMS, then for a while we were an extension to ArcGIS Server, and 7 years ago now we extracted ourselves from the ArcGIS technology because we just focused on this metadata and discovery and search technology that was independent of Esri technology. It then also became open source under Apache license. And we've been working on this since then. Using it in our own projects with customers. I am in our professional services organization, but also making it available for people to deploy and install themselves and configure themselves. Some of the examples of use, right? So Geospatial Platform is here in the US a national program for making data from federal, state, local government accessible throughout. Before the Geo platform, there was a program called Geospatial One Stop. That's really where the Geoportal Server originated. If you look at these agencies, NOAA, EPA, Department of Interior, DHS, in many of these places you'll find Geoportal servers either internally or even externally facing, such as the EPA Environmental Dataset Gateway, which is built on our technology. Geoportal Server also is used in international settings. So here's GeoSUR is a Latin American focused spatial data infrastructure, if you will. That is a website that aggregates content from the Latin American countries, South America, Middle America, Caribbean. And that is using Geoportal Server since many years ago. And you can go there to find data that is also discoverable in national portals in each of these countries, but the convenience is you don't have to go to these individual countries. You can find similar content across those countries. At a global scale, we've been working with the Group on Earth observation in a slightly different role. This is also a little bit of, if you think about where the Geoportal Server is going. Group on Earth observation is essentially a network of networks, right? So each one of these acronyms around the central bubble is not necessarily one single organization, but IUS, the International Ocean Observatory System, is itself a network of organizations. For example, NOAA is part of that here in the US. The World Meteorological Organization brings together the national meteorological services. They exchange data between themselves. So Geo is essentially connecting all of those different networks to each other. ArcGIS Online, in its sense, is a network as well, right? Many different organizations use it. They share data within ArcGIS Online. So one of the things we have done with Geoportal Server there is to actually bridge between this Group on Earth observation network and the ArcGIS Online network, by providing catalog services, by providing some tools in desktop and so on. Now, if you look across those different catalogs, there's a number of experiences that we have seen over the years. If you look at search in general, precision and recall are two terms that you really want to make yourself familiar with if you haven't already. Because those are really looking at the quality of the search or the search experience, if you will. Right? So if searches are not useful to your users, precision is low. Right? You get a lot of hits, right? It's great. I get 5 million hits, but right? It's not really what I want it to look for. So that's not good. And the other side of that, the flip of that coin, is recall, and that is you're missing things, right? So you might miss things that could have been useful to your user, and they didn't show up in your search results. And that's part of the thing that we're trying to tackle in Geoportal Server. And that is hard because what we see is incomplete descriptions, right? Incomplete descriptions in metadata, people don't fill in things, right? It's hard. Metadata is always an afterthought in some ways, but it's really important, right? If you're a climate scientist and you're using a data set from the 90s, you need to know that this was a data set from the 90s and that the situation right now is different from what it was then, right? So documentation is not just for your current use, and some of these, what you'll see here, if I open up a couple of these links, right? So this is an ArcGIS Online, and you'll see, and I saw it actually in the plenary also, if someone does a demo, they need to register a web service, but for the purpose of the demo, they fill in demo for the description and the abstract and the tags and so on, right? So that's not really helpful, right? So yeah, it's great that they're there. Template assets for Reality Lens demo, and that's about it, right? Anyway, so not to kind of sort of criticize those things, but this makes searching really hard, right? So fill in your descriptions. Another problem that we see is broken links. And broken links happen because of retired web services. Because we're just metadata, right? We don't actually host any web services ourselves other than a catalog service. But we don't host map services, we don't host geoprocessing or those kinds of things. We rely on others to provide those. And those others need to actually do something to make sure that those services are up and running. If you change your URLs, things get broken, right? So if you're in the federal government, there's now an HTTPS only directive, essentially, right? So all government websites need to implement HTTPS and start switching off from HTTP. Well, your web service in ArcGIS Server was referenced in metadata that you published to the Geo platform maybe a year ago or so, right? Are you actually going to go back to the metadata and update that? If not, then your web service might at some point not be usable anymore because of HTTP versus HTTPS sort of clashes that might happen. One way that you can help that is inform your users. So what this would open is a site on the GeoSUR portal that actually shows you of a set of services that they have published, the status of those services. And one of the things we have done, this status is actually determined by what is called a service status checker. It's actually a tool that the Federal Geographic Data Committee, FGDC, makes available. What you can do is you can register your Geoportal with that. They will then go and crawl your Geoportal to find if you have web services in your Geoportal. If for a number of those web services, they can then actually check, is the service available? Is it up and running? Does it perform well? Does it comply to the OGC spec? Does it have some form of metadata? Can I actually interact with it? Right, so the GeoSUR site actually informs their users of the status of their services. Right, similar, ArcGIS Online does that with its services, but it's not typically done for map services and feature services and those kinds of things. The other thing is that, like I said, right, the recall, if your search results are not complete. So I have two examples from BLM, Bureau of Land Management here. So one is a Geoportal Server site that they operate, and that server site has, as you can see, just over 8,000 things that are there. It's a public site, right? So, okay, this is open data, public data, I can get to it, and so on. If I go back to the slide and open up the sort of BLM presence on data.gov, data.gov is the sort of government open data site that was created a number of years ago. I only see 97 data sets. Right, so for some reason we went from 8,000 to 97 between those two different catalogs. And that makes it, if I go to data.gov and look for BLM data, I'm not going to find what I would find on this BLM data set. There was a question here.
Sure. I work for BLM, and our policy is to push to data.doi.gov, and data.doi.gov will push to data.gov.
Exactly.
And that link between data.doi.gov and data.gov is broken right now. And we've brought somebody in to work on that.
Sure, and the point is not, right? The point is to point out that depending on which site you go, you may get less or more results from a particular source because of these types of things, right? So I don't know if everyone is familiar with this. So data.gov asks government agencies to register a particular data set, a listing of their data holdings with data.gov. And so BLM being part of Department of Interior, they feed up through Department of Interior, and then Department of Interior feeds into data.gov. Along the way, things happen, things don't get registered, things get filtered out for some reason or so on. But I would rather find 8,000 things than 97 things. Okay, so downloading data, I won't go through every one of these. NOAA has a large initiative on making their big data available, NextRad being one of those. The GOES-16 satellite that was just sort of came into operation is going to be the next one that is going to produce enormous amounts of data. And NOAA is looking for partnerships, and they're working with Amazon and Microsoft and others on making their data more usable and more accessible. NextRad is of interest for weather companies and emergency response agencies because it provides them with the alerts and other kind of warnings that they need. But NextRad is big data, and it's, well, I want to say weird data, but it's hard to read because it's radial data sets and so on. Well, one answer to that is to kind of serverize your data, right? So rather than downloading terabytes of data, make your data available through image services or other types of web coverage services if you want to provide OGC services. License your data is important, right? So tell people what they can and cannot do, or should and should not do with their data, right? To avoid driving into the river because your data set said there was a bridge, but it was removed a while ago. And then there's things like user experience design you've got to think about. So those are a couple of experiences that we're trying to tackle in the GeoPortal. I'm not saying we're getting it right, but we're evolving the product as we go from a kind of a user search experience and user experience perspective. Now the other thing is that what we have seen over the last decade is the size of the catalog matters, right? So if you're a local government, you typically have a few hundreds of data sets. This is what we see, right? If you're in a state government or a single BLM sort of organizational site, you might have a few thousand data sets. Part of that is because you simply aggregate content from individual counties or local governments into the state level catalog. ArcGIS Open Data, right? If you go to opendata.arcgis.com, there's about 63,000 data sets. I checked this yesterday, and so it's growing. And the number of data sets that people make available there is growing as well. ArcGIS Online itself has a lot more content, right? So there's that same situation again, right? So filter for some reason. Data.gov at the moment has just about 200,000 things, right? So these are all sizes of catalog where the GeoPortal server technology that we have developed over many years suits very well. A single server that can handle this with, we use Lucene in that version, and that works really well. Over the last years, we've been working with NOAA, particularly. I mentioned NextRad, but NOAA does a lot of surveys. And so there we ran into catalogs of potentially hundreds of millions of data sets, right? So an individual raster data set for a NextRad observation, or an individual survey, or an individual image scene, right? A scene within a Landsat picture, right? Or Iconos, or however many satellites. The GeoSUR satellite is going to produce many, many images each day, each of which might be of interest to some researcher or policymaker in some way. Right, so how do you handle that? Our technology that we had in GeoPortal Server was simply not enough, right? So what we realized is there was this universe of kind of vector data and small data that we were used to work with, right? Street data sets and so on. But then we discovered there was this other universe of Earth observation data. And if you think about drones, if you think about IoT, the number of data sets and types of data that are going to be collected is going to explode over the next few years, right? Or is exploding. So we needed to do something. And that meant for us that we started essentially a new generation or new branch in the GeoPortal server development, where we had version 1, which was based on Lucene and had a database behind it and a few other things, right? So that was great. We've been developing that over the last years. Last year, we started with version 2. And I'll go through what these mean, and those two are now in existence in parallel, right? So we're not fully stopping our development on version 1 because there's many users out there that use it, and we'll provide patches as we did in January, where we found a vulnerability that we resolve, and then we make that available to the users. But at the same time, we're putting more and more of our attention into version 2. And we just released version 2.5 of that. I'll go through some of the capabilities of those two. So Geoportal Server 127 has been sort of our leading version, and the 1.2 version, I should say, for a number of years, right? So it's built on Lucene, like I mentioned. It works with Oracle, SQL Server, MySQL, Postgres databases. To store a lot of the information, and over the years we have done a number of enhancements. It's a reference implementation for CSW 202 and CSW 3, so we work very closely in the OGC context. We have supported OpenSearch for many years, and we have sort of gradually built out some capabilities. One of which really is the support for what agencies like BLM, Department of Interior, or EPA need to do in the context of data.gov. So that format that data.gov is asking you to provide, the file that you need to provide is in DCAT format. DCAT is a W3C specification to describe a catalog, and it's different from ISO or FGDC metadata. There's different fields, the structure is different, there are some fields that don't exist in FGDC or ISO, and vice versa. There's things that are different. So we've put a lot of effort in creating mappings between FGDC and DCAT, and ISO and DCAT, and allowing you to configure the GeoPortal to really provide a DCAT file that you can then register with data.gov that is as compliant as we can make it. And DCAT evolves, data.gov evolves, and we'll just continue to evolve with it. And we're working very closely with, for example, the EPA on that. Another thing is, in this process of going from BLM to DOI to data.gov, or going from NOAA to data.gov, or going from EPA to data.gov, or going from your agency to the Geo platform, or from a country national portal to GeoSUR, the thing involved is called harvesting. And what we've noticed is sometimes the harvester that we set up, it was sometimes blocked because it was perceived as a kind of an intrusion, because we're sometimes harvesting thousands of documents. And when this harvesting process starts, we very quickly in sequence send a lot of requests to a server. Give us your data, give us your metadata, I should say. Give us your metadata, give an updated metadata file, and so on. And that one of the things we have done is implement the sort of adherence to the robot.txt file, right? If you own a web server, you can put a robots.txt file in the root of your website that tells crawlers what folders to crawl and what they are allowed to crawl, what they are not allowed to crawl. Right, so and that means that you can sort of guide a crawler like the Geoportal Server Harvester to certain folders and avoid that it kind of loads your system with all sorts of requests, right? Denial of service attacks, because that's very easy to do in a harvesting context. So that's a thing that we implemented, and of course, sort of some metadata editing being a key thing there. So Geoportal Server is on GitHub, right? So go to that repository and you can find what we're doing, what we're working on the Geoportal 1.2 releases, and follow the discussion. We have issues there on GitHub, and I'll show you that in a second also. So in parallel to that, we released this 2.5 release. Or actually, we started with 2.0 last year, and it's we just released 2.5 a couple of weeks ago. We switched from Lucene to using Elastic, right? So one of the ways that we can scale the GeoPortal itself in terms of how many documents it can handle, we simply ran into a limitation with maybe a few million, 2 million or so documents in Lucene. A single node was not performant enough, the publishing took too long, etc. So with Elastic, you can set up a cluster of nodes, and you can therefore sort of scale the publishing speed, the search performance, etc. The other thing that we get from Elastic is sort of no need for a database anymore, right? So we don't have a relational database in Geoportal 2 anymore, which makes deployment easier, and sometimes it makes the sort of complying with internal IT regulations easier because you don't have that thing anymore. We released 2.0 last year, and there was Elastic 2. Elastic came out with version 5 not so long ago, so we decided, and that's going to be sort of their path forward. So we decided, well, might as well do an update now as we're still building out this 2.0 release of the Geoportal. So Elastic 5 is what we support in this 2.5 release, hence the 2.5. We support OGC CSW3, which is the newest OGC spec, and OpenSearch. And we also switched our map viewer. So in the past we had like a Flex viewer, and there was a time where we had Silverlight viewer. And then, well, those technologies are finding their way to the green pastures. And so we decided to not build a viewer. Our goal is not build a viewer, right? Because we're a catalog, we're search focused. So we enabled some integration with a viewer that you could configure and build in Web AppBuilder. And it's integrated with Geoportal, but it's something that if you want to change it, you just build a Web AppBuilder based viewer, you put some widgets in it that we have available to do the integration, and you have your own viewer, right? You don't have to use what we provide. We also built a search widget that runs inside Web AppBuilder. That you can use that with the Geoportal itself, but you don't have to. You can run it, build your own Web AppBuilder viewer, and if you want to provide search capabilities in it, you can then plug that widget in there. I can show you an example of that also, and do searches from that viewer to one or more different metadata catalogs. Right? So it's a role of Geoportal in terms of providing search capabilities to both Esri and non-Esri catalogs, not just in the Geoportal website, but in other applications and products as well. Right? ArcGIS Desktop is one where we have had an add-in for many years to search the catalog services. And then I showed you that one screen with the status of these services. Well, we provide that in Geoportal 1, and obviously we sort of ported it over to Geoportal 2 as well, and do the same kind of status information in Geoportal 2. As you see, the GitHub catalog is different, right? So we started a new GitHub site. Simply because documentation will be very different, the code is so different, and also because we have kind of separated out the harvesting function. Right? So in the Geoportal 1, the harvesting was just one of the functions of Geoportal Server. In Geoportal 2, we separated that out into its own application, and one of the reasons there is that you can use that harvester without a Geoportal. Right? You don't, if you just need to move metadata from one place to another, you can use the harvester. If you want to collect metadata from someone else's catalog into your local folder, you can use the harvester. And actually, what we're working on is also to do some processing, right? So if you need to move your FGDC metadata to ISO metadata, that's a lot of work. Your data might exist in many different folders on your network drives or network shares, and going through those might be quite hard. One of the things we're doing with the harvester is provide transformations, right? So we're going to build some transformations between FGDC and ISO, or between FGDC and DCAT, right? Or you name it. And then use the harvester essentially as a big translator between those two metadata formats. So that's a kind of a neat thing with Geoportal 2. Now let me go through a few examples here. Just a little time check. All right, so I have this is a public site, geos.esri.com/geoportal2. You can go there if you want to and play with this yourselves. We've had a sandbox site for many years, and this is kind of a flavor of that in the version 2 sense. Okay, so if you know Geoportal 1, right, you saw the BLM site. The first thing that is going to be different is that we essentially start with everything, right? So in Geoportal 1, you start with a blank screen and you do a search and then you find something, hopefully. In Geoportal 2, we've taken the opposite approach, and it's almost like when you go to Amazon or when you go to your home improvement store, right, where you can search for products. Right? On the left-hand side is a list of what we call facets, right? So Geoportal 2 supports faceted search, which is really one of the neat things that Elasticsearch provides us, right, without a lot of effort on our side. And those facets essentially allow you to get a little view of what's actually in my catalog, right? So there's about 3,457 records in this catalog that are published by USGS. And there's 545 from the gravity and magnetics organization within that. If you look at metadata types, for example, right? So there's a lot of FGDC records, there's 2 ISO records, and there's 1 ArcGIS metadata record. So the idea is you can get a view of what's in the catalog without actually having to type and guess keywords and guess things. And that's really easy because it allows you to very quickly sort of filter to one specific metadata item or a collection or a few items that match your particular needs. One of the things we've done is, for example, to expose these 2 different dates, right? So metadata has many dates, right? If you're familiar with metadata. The date of publication, the date the metadata was written, the date the data set was updated, the date the data set was originally created, the date it was published to the catalog, right? So there's all these different dates associated with metadata, and searching for dates is not really a trivial thing. What we have done here is expose 2 of those dates. One is the time period as defined in the metadata, and the other is the date it was published to the catalog, right? So it makes sense. And so what I can do, what you see here is that there's a lot of metadata originated or applicable to sort of the 2000s, right? The first decade of the 2000s. There's actually one for 2994, whatever that is. What I can do now is I can filter this date using a little slider and essentially zoom in on this time period for which the data was applicable. Right? So instead of guessing dates, I'm just filtering based on what I see is in the catalog. Right? So filter by date. I want to get a little more detail. I can maybe do it by month here, right? So you can see, well, there's a lot of data still there. So I mean, even though my filter doesn't really cut down on the catalog itself, right? They still have 1,000 items, but it allows me to understand if I'm looking for data for, say, the 2000 period. I know that I can ignore all of these. What you also will notice is that as I go through this one filter mechanism, these other facets obviously get updated, right? So there's 668 there, and there's an hour later, there's a few more, right? I can zoom in a little bit closer, so filter a little bit closer here in terms of when things were published. And you can see we were publishing this over a period of maybe an hour or 2, and during that time we harvested these documents actually from a USGS website. Right, so that's the mechanism of facets, and you can see that these USGS sort of keywords facets also got updated, right? Now there's also a map, right? So I can see here if I just start over again by removing this this one here. Yep, all right, there we are. If I zoom out a little bit, you can see that we also kind of show you where the metadata is at in the globe. And Geoportal 1, we did this with these little rectangles, right? And at some point they overlap each other and you can see data there. What we have done here is essentially do aggregations based on some sort of grid. And the bigger the bubble, the more records there are kind of centered around that location. And I can still do things what you were used to with Geoportal 1, right? So filter within that particular extent, and that filters down my content, right? And of course I can combine these, combine time and other facets. I can still do a keyword search, right? So if I do try a search for WMS, there's some WMS services here in this area, and we can then see those, and you can see there's some things that I can now supposedly add to a map. Right? And as I hover over, we still show you where that thing actually is. Okay, let me try that here. All right, so not my service, so disclaimer. What this will do is it'll load this Web AppBuilder based viewer, and it's then going to connect to that service that I just found in this site. I'll just let this roll for a while.
Sorry, while it's loading,
Yes?
If the Geoportal is open source, then what does that mean for that Web AppBuilder?
The application that you build with the Web AppBuilder, you can open source that also. Yeah. Right, so obviously JavaScript libraries itself are not sort of open source in that sense. Yeah, you can see, right? That's too bad. Okay, well that's one of those experiences. So the point is that Geoportal Server is open source. The viewer that we make available is itself also open source. And then if you want to build your own viewer, you would just use the Web AppBuilder, and the application you generate from that, you can then make open source as well. Okay, so this is like a Geoportal 2 in a fairly standard configuration, right? So out of the box facets that we define and so on. However, I mentioned these image catalogs, and one of the things that we have always been able to do with Geoportal Server is really tailor the index of the metadata that we create. And so what you see here is a different catalog with about 600,000 images, individual images, coming out of a few image services that we have indexed. And then basically the facets we have configured to be specific for that catalog. Right? So that's a key thing to realize here. So there's still acquisition date, obviously, but for example, here there is also a day of the year that the day that a particular image was acquired. This is important if you have like leave on and leave off situations, right? Some of the imagery you want to get when there's no leaves on the trees because you see more. Or maybe sort of the angle of the sun or things like that are important because of where your data is, right? So, or in many image collection, visual imagery especially, right? You want low cloud cover. Okay, so let's get low cloud cover. And if I actually click there, all right, so there's 200,000 of these that are low cloud cover. Now what I didn't show on the other side, so the facets are different. The mechanism is the same, right? And you can actually configure your own facets. And facets could be little charts like this, or they could be simply keywords that you have, like the owner here. I think there's only one owner. The year of acquisition, or in this case the data set, right? So this has POT6 and Landsat 8 data. I can filter between those, right? So if I do that, and then, so what I'll show is sort of a little bit of the structure that's behind this. So like I said, we use Elasticsearch. Elasticsearch basically stores a lot of things as JSON, right, inside it. And it can index that really efficiently and make it discoverable efficiently. So essentially what we do is we're not moving away from XML, right? We love XML, right? But when we store it, the index uses JSON as its internal structure. So we basically extract fields out of the XML and put that into the index. Similar with Geoportal 1, if you have FGDC, Dublin Core, ISO, Gemini, Inspire, SDSFIE, metadata flavors, and that's only a handful of dozens of different metadata profiles, a title is always in a different place, or keywords are in a different place, or the period of the data itself is in a different place, or notated differently, right? FGDC dates are very different from ISO dates. So what we do when we index things in Geoportal 2, we pull things out of that metadata, out of that XML, and put it in the structure in this standardized way. And you'll see a number of the things that you saw in the facets, right? So zenith is a long value coming out of that data. The acquisition date is a date, and so on. And you basically create your own structure, and you can index whatever you like. And based on that, you can then configure your own facets in the Geoportal. Right, so that's a view on sort of the insights. As you can see, we collect all these links. Those links are then exposed in the application itself. And so, for example, I could sort of open up this browse picture of that one scene, which is not the most interesting one, but there's no clouds at least, right? So we're good. This must be over water or something. Right, so that I hope you get the picture there. So the point is that of Geoportal 2 is that you start with the full catalog. You configure your own facets, and then by filtering down, whether it's through keyword search or based on the facets and combining and say, okay, I like this Landsat 8, let me look at something else, right? So I just remove one of these facets, right? My filter now, my data set went bigger. I'm now looking at everything that I had collected about this Landsat data. So we'll get a little closer here. search within, and so there you go. Right, so we find some items here, and now we should actually get a picture without water, with a little bit of cloud cover. Right, so that's the idea. I can then do something with this in my own application, and that's the part of some of the work that we're still working on with, for example, Noah. Okay, so what do you do now, right? Where do you take it when you have found this this new thing? So one of the things also is we have obviously some login here. Do I do this correctly? Which one is this? This probably is this. There you go. Right. So we have some login, and one of the things we have done here is the ability to create metadata. I'll show that later. So this ability to create metadata is one of the key things of Geoportal Server, and I'll show that later for a good reason. So let me go to the harvester then. Right. So I said harvester is now its own application. And one of the things that allows us to do is add and do things with the harvester that would make it a little bit difficult in Geoportal 1 because of the tight integration between the harvester and the Geoportal catalog itself. So this is very much still a work in progress, right? So a very simple user interface, really the developer's view of the harvester. And one of the things we introduced here is brokers. And there's input brokers and output brokers. An input broker allows you to configure the source you are going to harvest. So data.gov has a CSW interface, and we can then harvest that. Right? So you can choose one of a number of different broker sources, such as the catalog service here. If I add one and I choose one here, right? So we can harvest from CCAN. CCAN is one of these other metadata catalogs that is quite popular in open data land. And we have been able to harvest from a CCAN into a Geoportal because sometimes that happens. For example, in the flow up to data.gov, some agencies deploy ArcGIS Online and CCAN and maybe Socrata at some point in the future. And we can then ingest those catalogs and then make it available to other users. We also have these output brokers. At this point, we have a few. We can harvest into ArcGIS Portal, which obviously includes ArcGIS Online. We can harvest into Geoportal 2, and we can harvest into a folder. And the idea of this is that I can then configure tasks. And I have a task here that I had configured. I actually, when I was preparing here, I saw there is a little bug in our application. Essentially what you do is you pick a source and you pick a target. You can actually pick multiple targets, right? So I can harvest into a folder as well as into another catalog at the same time. Right? This is one of the big differences in Geoportal 1. So I'll just run this task that I had configured. When we run it, you can schedule it. You can schedule it at a certain time, or you can schedule it to happen daily. And of course, as I said, we implemented this good behavior. I'll ignore this for now, so that we can actually harvest some things. So I just started the harvesting job. And what you see here is it's going to instantiate the harvesting job, and it's actually harvesting data from FGDC right now. So if I go to my local folder, because I'm harvesting into a local folder, you see that we're apparently starting to harvest airborne geophysical surveys, and it's counting, right? So 85, 88, 90, right? So this kind of gives you a little bit of an idea of the speed. This speed is mostly determined by download time, right? Because we're harvesting documents at a time, and it has to download each one of these documents. So let's not overload that USGS system too much for just a demo, right? So I have a harvesting job now. Now what I could do if I see if I can make this work here. This is the USGS WAF. So I harvested into this folder. What I also did is I registered that folder as an input source, right? I can harvest from that input source. And then I'll harvest into my Geoportal server here. All right, so I have now a second job, and I can then run this job. Right, so ignore this, sure. Right, so now I'm harvesting from my local folder into my local Geoportal, and that's the one that I have here. Let me just refresh that. right? So this is still going, right? 77 per minute, 81 per minute. We're coming up to 300, 400 documents per minute in terms of publishing. And if you think about having to publish the number of documents that we run into with, for example, NOAA, then that's getting up to a speed that we can actually work here. All right, so this is still going. Let's see if this actually does something here, the date. You know, I actually harvested a number of these things already, so that might actually show that we're not seeing more things, right? So we're harvesting, right? So you can see the 28 is aggregated here. Those are documents that are being published here. Right, so those are documents that are new that were published today. Okay, so that's sort of on the harvester. So the idea is you can configure these brokers, you configure tasks, you can schedule the tasks, and then you run it to harvest into your own catalog, into ArcGIS Online, or into Portal, or into a folder or something. And obviously this is extensible, right? Also the harvester is open source, and also the harvester can be extended with other things. So the GitHub repositories are Geoportal Server catalog within the Esri environment, and between those two, the new Geoportal and the harvester, you can sort of easily switch between them. One of the things you will see here is, for example, some of the users in this the harvesting catalog have started to look at OAI and Data One as potential data sources. Right? So we work with some developers outside of Esri who are developing their own harvesters into the Geoportal 2, and they're contributing those as well to the Geoportal code base. All right, so that's sort of the harvester here. Okay, let me move forward. Right, so let's go to where we are going next with these two particular versions. So we're working on sort of a next release of Geoportal 2. We're aiming maybe for the user conference or so. And if you look here to the list, well, we're still catching up, right? We're still catching up with sort of functionality that is available in version 1 that we don't have yet in version 2. And we're prioritizing what we're doing based on the discussions we have with NOAA, EPA, USGS, BLM, actually, and a few others, right? So what is important? Well, for example, DCAT is important. From NOAA, we're hearing they like the KML and the HTML outputs that you can get out of Geoportal 1 because it allows them to embed little views of metadata into other sites, right? So, and the EPA uses that on their environmental dataset gateway. We did not implement CSW 202 because there is a new flavor, but we're sort of maybe ahead of the curve here, and people are asking for CSW 202, so we're considering that also. Lots of questions around previewing the metadata, right? Not just the JSON view, but sort of nicely styled HTML view of the XML that was published, etc. Approval status. So at this point we don't have that in the Geoportal 2, but in Geoportal 1 you could have like a workflow around metadata, right? So something was posted, something got reviewed, something got approved. Also assigning it to be discoverable only by a few people through collections and restricted metadata, similar to the groups that you had in ArcGIS Online. And then some whole things around user management, self-care, LDAP integration, and all that kind of stuff. On the harvester, we're really hoping to work on a nicer user interface, although that is not the point, right? The point of the harvester user interface really is to allow you to just configure a job, essentially, schedule it, and then the server will do the rest, right? The point of the harvester is not to be used very often. However, things like OAI, which is coming from the library sciences, Data One, and other types of catalogs, and we need to hear from you what you're seeing, harvesting those into our own catalogs, these processing capabilities, right? So XSLTs, those were the things we're going to work on next on the harvester. Now, I mentioned we have some widgets. Let me see, I think I have some time for that. So I'll just open up a viewer here that is also public. And there you go. So this is a Web AppBuilder client that we developed as part of our work in the OGC testbed. Right, so we participate in the OGC testbeds, which basically means we experiment with others. I don't need that, thank you. Where we experiment with others on connecting Esri and non-Esri technologies. Right, so that's through OGC interfaces. And the idea is that based on the experience, we further the OGC specifications. Let me see this. Why is this not working here? Is that not happy? That is not nice. Okay, maybe I won't show that. That's too bad. Okay, I won't show that because it's not responding for whatever reason here. So that I'll take a look at that. It works, but it worked. Let me continue on then. So the point of that is that sorry for that. We have this a widget that you can use to search other catalogs. That's basically using Geoportal Server, sort of behind the scenes. We also have a widget that starts to look at using what is called OGC context documents. Those are documents that you can list a number of web services in and basically create a map. It's almost like a web map that you then load into a Web AppBuilder application and then use the services that you found in that particular context document. So the idea is that one of the things we're doing with Geoportal is provide some search capabilities sort of in different parts of the ArcGIS platform, right? So ArcMap, Web AppBuilder, web clients, etc. The other thing that we have focused on a lot of work is on metadata. Since a year and a half, ArcGIS Online has metadata capabilities. We actually developed those based on the Geoportal Server metadata capabilities, right? So my team is developing that particular part of ArcGIS Online and Portal for ArcGIS as it became available a year ago. And what's interesting is that metadata editor is actually in the JavaScript API, right? You can create your own application with the metadata editor from the JavaScript API to do metadata editing in a web client. And what we have done is create a few examples of that I'll go through, and then we can extend it, right? So even though in ArcGIS Online there's only 5 different flavors you can choose, right, for your subscription, with ISO, FGDC, Inspire, and there are 2 different ISO flavors. And in the Geoportal instance of that, in your own instance of that metadata editor, you can actually extend it with other metadata types. And one of the things we've worked on is this SDS FIE, which is a military installation metadata specification that is used in, for example, the Army Corps. Right, so that's a thing that we're going to work on. If I open up the metadata editor in Portal for ArcGIS, if that is still good. That's because I am kind of editing my my own metadata in that thing. So here I would be able to ingest some metadata. Let's see, input XML ArcGIS. So I have some ArcGIS metadata here, right? So this should be okay. And it's going to populate this document here. Right, so and I get a metadata editor. And this metadata editor essentially follows the structure of the metadata you just loaded into the editor. Right, so a tabbed interface, you can have abstracts, and you can see some editing capabilities using HTML markup and so on. Repeatable elements, right? You can have additional things that you want to add. This is typical of sort of the standards-based metadata that we see in our world. And I guess this is the ISO 19139 specification. So this editor is part of Portal for ArcGIS. Let me just save this. And it's stored in Portal for ArcGIS. Right? So every item in Portal for ArcGIS, every item in ArcGIS Online can have your standards-based metadata. Now what we then also did, because the metadata editor is part of the JavaScript API, I built a little application that essentially connects to my ArcGIS, my Portal for ArcGIS, my local Portal for ArcGIS, and then it shows me my items. And what I can do here is actually open up the metadata editor also. I'm not working in Portal here. I'm working just in a JavaScript application, and that I'm hosting here locally. The beauty of this is that now I can actually add my own metadata specifications to what is available in Portal for ArcGIS. Right, so this is a way to, and this is work in progress, a way to, right, so this is the metadata I just loaded here, and it's the same metadata, right, but it's now in a different application. And so we're going to expand on this in sort of the next period to allow you to do other things. And for example, this metadata is stored in Portal. You can actually do this also completely outside of Portal and just have a metadata editor that works on local files. Right? So in this case, I've configured another JavaScript application, one page essentially, that allows me to open up a file. And if I open up that same file as an example, I'm editing this file, I can then save it back to the local file. Right? So if all you need is an editor for local XML files, you can build that with, or we can send you this HTML file, you can build that with the JavaScript API very quickly using the metadata editor that's part of that. Right? So the same sort of user experience. In this case, it's formatted using the ArcGIS metadata style, etc. But I could also, let me open this up again, start a new document from here. And in this case, I have configured this SDS FIE metadata schema as an additional schema that is not part of Portal, not part of ArcGIS Online. And if I then I'll just view the XML here. One of the reasons you can see this SDS FIE is different namespaces, right? It adds new elements to it, it adds new attributes to some of the elements, and it has a few namespaces of its own that are used in that community. So that's kind of that metadata editor, and let me just go and show you how that really works. Over here. So the last editor I showed you is this page, the one with the ArcGIS portal carousel or gallery that I can then open up into my editor is the index file. I broke out some styling in JavaScript. That's not even necessary. The key thing here is that if you want to add your own metadata profile to this, you can do that by creating a structure similar to this, right? So you basically define your SDS FIE, in this case profile. It extends the ISO GMD elements for metadata entity, for example. And then we work with two things. We have, so in the Geoportal 1, it was all XML files that you would be editing to create your own metadata schema. Now it's JavaScript and HTML fragments. So there's a JavaScript file for each of the sections and elements that you would then show. And for example, this metadata standard, I think I had it open already. It's this one over here. So essentially what you do is you just define the page that you're working in, and then you define what is the target, right? So what is the target element in my metadata And if you follow the hierarchical structure of your XML, right, you don't have to have the full paths and so on. But essentially it says put the metadata standard name and then pick up the proper language file and label for that. There is in the case of this SDSFIE, it's not a character string, it's actually a code that they have assigned to it. So they have created a new sub-element of the metadata standard name, and that is the metadata standard name code. It's a code list. Which code list does it come from? That's the URL that you see here. And then what is its value? It's SDSFIE metadata, right? So you basically work your way, and then the same similar for version, right? So, and these are fixed values, as you can see, and therefore not editable, because that's always the value for this particular metadata spec. And that's how you then configure your profile with additional elements. Once you do this for all the elements you want to change, you basically then define this new metadata spec in your application. Let me go there, and we're going in this one here. So what you do in the configuration of the metadata editor is you essentially define your own metadata types, right? So this is my SDSFIE metadata type, and there's a few things like this that actually tell the Geoportal or the metadata editor where are the configuration files for this particular one. And one of the things that's important for us is what we call the interrogation rule. If we get an XML file that someone tries to open, we have to understand which flavor of metadata is this. And we use this XPath expression to recognize that. And then there's a few other things like the standard name and value that we can populate. But you also see other flavors here, right? So FGDC metadata, ArcGIS metadata looks a lot like FGDC metadata, right? It's a lot of similar elements, but FGDC doesn't have or shouldn't have this Esri element with some of the things that we like to store about your metadata. For example, are some of the fields synchronized with the actual data, right? Which is what you can do in our catalog. There's no place for that in FGDC metadata, so that's why Esri has a few specific elements there. ISO, Inspire ISO. Inspire is a European metadata format that is derived from ISO, a profile of ISO. So we have to kind of recognize it compared to the ISO metadata that NOAA or others here would create. So this is how you would sort of configure your own profile by creating these additional sort of HTML snippets and JavaScript files that go with them, and then defining that particular metadata profile. There's a few other things you might need to do, but we can talk about that later. So this is kind of a view of what we're working on with Geoportal Server, right? So Geoportal 2, search capabilities, faceted search, harvesting, its own separate application with sort of input brokers, output brokers, and soon to be processes that you would apply as part of the harvesting job, extensible with your own if you want to. And then search widgets for various places. And metadata editing as its own thing, right? So one of the things we're doing is, can we build this application that I just saw, that I put together yesterday based on an example from the JavaScript API to fetch my content items in my portal and then connect my metadata editor to that. Can we build it into something that might be used by you to edit metadata in ArcGIS Online in additional metadata profiles that ArcGIS Online doesn't support or does not yet support or so. Right, so that might be something to think about. Okay, so we have a little bit of time, I think, for some questions. Well, feel free to answer questions if there are. Yes?
What funds the maintenance and upkeep of this?
My boss. Geoportal Server is open source, is free. And so there really is no funding. Actually, that's not entirely true. You can buy support. Obviously, support on GitHub is free. We monitor GitHub. We answer 2 questions. We have some distributors who are quite active with Geoportal Server who answer questions and contribute things that they do. So there's, in that sense, there is no funding needed for that. Jack is committed. I mean, Jack is really committed to this technology. for many years, as he is committed to making data discoverable, usable, and as a resource. You can buy technical support, in which case you can actually call tech support and they will answer your questions. Sometimes they will forward the questions to us as the development team to provide those answers. But otherwise, there's no funding for this. Question back.
Can you harvest from that enterprise database? I might have missed that.
Oh, that's a good point. So harvesting from an enterprise geodatabase. Our approach so far has been that you would use actually an add-in that we have for our catalog or ArcMap that would essentially push things from your enterprise geodatabase into a Geoportal instance. But we will add sort of the ability to harvest from, right, using the new harvester to configure a geodatabase as a source. Yes, that's a good question. Point with that is that sometimes the Geoportal or the harvester is in a place sort of in your network that it cannot connect to the geodatabase. Related to this, I find very frustrating is you go to a website, you find metadata things there, and it's interesting. You look at the connection information, you see the SDE connection string. Well, that's not useful for me because I'm outside your firewall, right? I mean, there's some limitations with doing that, because what do you do once you find something, right? Other than knowing it's in this particular geodatabase, the ideal would be to then somehow be able to connect to it, right? So that's a thing there. What question here?
If I understood your harvesting demo correctly, you did it in two parts where you harvested from an external source to a local directory and then from a local directory to your Geoportal server?
Yep.
Is it always done in two parts like that?
No. You can also harvest directly. One thing that I didn't show is, for example, I need to go to this one over here. So what I did actually to load that USGS data, because it was the same data in the first website I showed, the geos.esri.com site, Geoportal 2. So what I did there is I wrote a simple Python script that connects to the USGS web accessible folder, right? They put their XML files in a folder on a web server. Anyone can go to it and you can read it. And essentially sort of crawl that site, start at the top, read the HTML, because those sites typically have an index page, right? And this is what comes back if you send a request to them. Correctly.
And just for my own understanding, I asked a question about harvester, and
yep.
now you're showing me Python.
Oh.
What is the relationship between harvester and Python?
So the harvester is completely scriptable, right? So the idea is you can actually run the harvester from the command line, or embed it in a Java application, or basically use it sort of as a tool inside a Python environment, right? You can also publish directly to the Geoportal if you want to, right? You don't have to use the harvester for that. And because the Geoportal itself has publication interfaces that allow you to input documents and update documents and delete documents and so on. So what I did is I basically parsed this page and find out if there's a folder, subfolder, etc. I mean, this is my own little harvester in some ways, but then written in Python. And then once I find a page, I then essentially just put it into the Geoportal using an HTTP put request, where I basically put the XML as the body, and I put some headers, right, my username and password to my local Geoportal instance, a few other things like that, and that's it, right? So that's a few lines of code to basically harvest and crawl other sources, right, into a Geoportal instance. Right, so creating a crawler for an enterprise geodatabase, that's going to be similar to this. Connect to the geodatabase, loop over all the feature datasets and the feature classes and the tables and so on, get the metadata through Python, and then push that into a Geoportal instance. Right, that's why. Yes?
So I was talking to the open data team.
Mm-hmm.
Not aware of these Geoportals.
No, we work very closely with Andrew Turner and Andrew Stauffer, and they.
What's future of these two products? Like,
well.
Close to becoming one?
Yeah, a very good question. So one of the things that because we are sort of a small team with mostly sort of external users, we're a little agile, right? So we can answer to a very specific question from a customer. So for example, DCAT implementation. We started that in Geoportal Server. And in talking to Andrew Turner and understanding that users are adopting the ArcGIS Open Data application, they recognize that there's an opportunity, and so they implemented DCAT as well in the Open Data application, and which allows people who have an Open Data site to then register that feed with data.gov or other sites that want the DCAT format. And similarly, we're talking to them about, for example, the catalog service, right? The OGC catalog service. It would be nice if, well, we actually have some implementations of a catalog service in front of ArcGIS Online, right? So that ArcGIS Online content is exposed through the OGC interface. That's not a production thing. We developed that as part of some prototyping that we're doing, trying to understand different functionalities of Geoportal, where can we reapply those and recombine those and so on. But so once something like this actually makes it into sort of a higher priority and a higher need is identified, it may actually just be implemented by the Open Data team rather than by us. Right, so we have a close relationship with them because a lot of open data sites participate in these national spatial data infrastructures. And for us, they are a source, potentially as a target as well.
So how do you compare the CCANs with the portal?
That's a hard question because I'm biased, right? But no, I mean, CCAN, maybe so from experience, right? So Geoportal Server was used to host the Geospatial One-Stop. When in 2009, when data.gov was just starting, they started off with 37 datasets, and within Geospatial One-Stop, we had 600,000 datasets. And we said, you know what, there is actually a mechanism that we can provide you with that content, and so we provided a catalog service interface to them. So then they suddenly went from 37 to 600,000, 37 or so, right, give or take. We then actually retired, the government retired Geospatial One-Stop, and it was merged into data.gov, and they used the Geoportal Server for that for quite a while. Then the CCAN, coming out of the open data world, applies very different specifications and approaches, right? So they're adopting W3C specifications, DCAT and others, and the sort of the Geoportal and the Geo Platform and a lot of other kind of sites are coming out of the kind of the OGC world, right? So it's like the OGC specifications, ISO metadata versus W3C and lightweight and RDF and those kinds of specifications. Those at some point will merge in some way or shape, right? Because both are good for specific purposes and so on. Functionality-wise, when they started using CCAN, they didn't have the harvesting capability that we already provided. So a lot of that had to be redeveloped in CCAN. We actually contributed the mapping from FGDC and ISO to DCAT to Project Open Data, and they were then used in CCAN as well. Right, so there's organizations who choose CCAN for reasons. There's organizations who choose Geoportal Server. There's other open source or commercial catalogs out there, and I cannot comment on why people would choose anything else but the Geoportal Server, of course. Yes, go ahead.
So how often Geoportal Server is used to have metadata for non-spatial data?
So a good question. So Geoportal Server you can register anything, right? It doesn't have to have a spatial extent even, right? So if my website actually works with me, so one of the things I did is there's actually an ISO specification for strategic markup language, right? May not be familiar with that, but it actually is an ISO spec. And so almost as an experiment for myself to understand how far can we take this, I've registered and created a profile, an XML profile for strategic markup language, which is nothing to do with metadata. This is actually a document format, if you will, right? It's not metadata, it's the document itself is expressed in XML. And so we did that, and working with a few sort of people outside of the geospatial world, we then configured this tool, the Geoportal, to allow you to register just XML documents. And so yes, it can entirely be used to register non-spatial content through reference, right? Because that's one way to register non-spatial content. It's a PDF file, and it's just a URL to the PDF. Or you can configure it to store complete XML documents of your own structure and edit those as if it's like a document management system almost. Right, so this is an example of that. And there's an editor for this also, right? So a form-based editor that is there. All right. Thank you for your attention. I hope it was useful. Find us on GitHub and have a nice rest of the day.